Hey, lesson 14, proving the Pythagorean theorem. Here we have a notice and wonder. We remember from the last lesson that these are similar triangles. Hold on, I'm going to push pause and draw them out. All right, I think this is so cool. So it took me a second, but I drew out the triangles, big, medium, and small. I needed to label the vertices as something, and there were so many letters out there already. I went with numbers to label the vertices. And then I transferred all of the side measurements to each triangle. If I look at the big triangle, nope, sorry, big triangle, I see that Pythagorean theorem is given with a squared plus b squared equals c squared. All right? Now, if I look at the medium triangle, my hypotenuse is b. And if I look at the small triangle, my hypotenuse is a. If I go back to the big triangle, my hypotenuse is c. So I look at that and I've got, whoa, that's a, b, and c. That's pretty cool. So I got distracted. So I noticed that A, B, and C, which I think is pretty cool, all in a hypotenuse, but A, B, and C is very cool. I wonder about that. Like, what does that mean? What else do I notice? Those are the things I think are cool. Let's see. If I look here, I notice that x plus y equals c, which is pretty cool. So I could actually do x plus y equals c. I think that's the only place I have the c. I mean, I could say y equals c minus x. I don't know if that does anything. And x equals c minus y. I don't know if that does anything. What else can I notice? 3 right triangles. The diagram is like the ones we worked in the previous lesson. What does H stand for? I don't know. I don't like it. H here would definitely stand for height on this side, on this triangle. H stands for height, which is cool. That is a good notice. And we know the triangles are similar. We don't have to wonder or notice about that. Okay, cool. Let's see if we can apply it. All right, prove Pythagoras right. Alina is playing with the equivalent ratios she wrote in the warm-up. I didn't write any equivalent ratios. Were we supposed to do that? I can say that, let's change colors. A over H equals, I'm just doing here, A over H equals, I want to make sure I get them right. A over X equals C over A over X equals C over A, that would work. So there's a point we want to make here, so I want to make sure I get it right, because if I lose you guys, I'll lose you guys. So I'm going to say A over X equals C over A. And if I multiply down, I would get A squared equals XC. Cool? Now if I did B over Y, I'm just doing this, B over Y equals C over B. So if I multiply these, I get B squared equals YC. Now let's do the last one. So first I did A over X equals C over A. And then I did B over Y equals C over B. Now let's see what else I can do. Ooh. I'm just noticing this. Still noticing and wondering. I have an a squared. I have a b squared. A squared plus b squared equals xc plus yc. That's cool. You see, I just substituted. Let's see if I can change colors. A squared, b squared. If I'm adding those two together, actually, let's set it up like this. I'm just going to recopy those two equations. I'm adding those two together, and I get a squared plus b squared equals xc plus yc. Now we're going to do some fancy algebra. I'm going to factor out the c's because they're common. And then if you remember up here, we noticed this. So I'm going to substitute. C times C okay, we just proved Pythagorean theorem without even knowing it because we're wicked smart. All right, just taking those ratios and noticing things. All right, if that was confusing, please rewind and watch again. I'm going to, well, this is going to be the same as that, just set up in a different way. Okay? Very cool. Oh, we were down here though. So sorry. So we just did the second task statement by Alina saying that and Diego saying this, and then Pythagorean theorem saying that. So how did Alina get from there to there? She cross-multiplied or multiplied down, no big deal. What equivalent ratios of side lengths did Diego use? He used the big triangle and the medium triangle, didn't he? B, Y, and C. B, Y, and C. Yep, he used the big and the medium triangle. By saying he did B over Y equals C over B. B over Y equals C over B. And cross multiplied. B squared equals YC. And then prove that in a right triangle with legs A and B and a hypotenuse length C. We did. C above. And an alternate approach. When Pythagoras proved his theorem, he used the two images shown here. Can you figure out how he used these diagrams to prove that a squared plus b squared equals c squared? Yep. Hold on a second. I'm going to see if I can do this in GeoGebra. I know in the past I've found a fun applet that shows how these work together, but I can't find it today. So we are going to deal with what we see here. So I have, let's look at this one. I have triangles on the outside and a square on the inside. So let's look at these triangles. I have, all these triangles are the same length. AB, AB. And we know the area of a triangle is 1/2 base times height. Okay, where it doesn't matter. Actually, I'm going to say 1/2 base times height. So I have a triangle. 1/2 base times height. Now, I actually, well, that's fine. We're going to deal with that. And we know that we're going to label this lengths of that as C. All right. So what I want to prove here is if I find the area of each triangle and there are 4 of them. 1, 2, 3, 4, plus the area of the square, it's going to be equal to the area of the big square. So I'm going to prove that the area of 4 triangles plus 1 small square is equal to the area of the large square. So the area of 4 small triangles will be 4 times 1/2. Hold on, let's get that written just a little bit better. 4 times 1/2 AB, so that's 4 triangles, plus the area of the small square, which is just C squared, equals the area of the large square. Now, base times height of the large square is A plus B times A plus B. Right? I'm moving past here because I'm out of space. 4 times 1/2 AB is 2AB plus C squared. Now for this right here, you guys have learned how to FOIL. Instead of AB squared, we're going to write AB times AB. And first is A squared. Outer, that's FOILing, right? You remember? Outer is AB. Inner is AB. And last is B squared. Collecting like terms, I get A squared plus, that's 2AB plus B squared. And that gives me A squared plus 2AB plus B squared. Now, I have 2AB on both sides, so I can actually subtract 2AB from both sides and left with C squared equals A squared plus B squared. I just did a proof of the Pythagorean theorem using this triangle. That's great. All right, let's see. Pythagoras used the 2 items shown here. This one, not quite as useful. I mean, I do have lots of I've got 4 little triangles, so I can do 4 1/2 base times height. I have a small triangle, a small square right there, which is A times A, and a big triangle right here, which is B times B. So that is all the pieces, the parts of the triangle, and that should be equal to A plus B quantity squared, okay, base times height. But I don't have any C here, so I'm not sure what to do with that. I'm going to work through this just to see what happens. If I FOIL this, I'll get the same thing as I did on the right, A squared plus 2AB, A squared plus 2AB plus B squared. And then that's on the left. On the right, I'll get 2AB plus A squared plus B squared. So really here I've proven that the left-hand side of the equation equals the right-hand side of the equation. Another way to prove it. All right, I hope you enjoyed that. That's sort of different and fun. And that's it for today.